Hello and welcome along to another lesson with Mr. Burns. In this lesson we're going to look at this word here, factor, or being asked to write down the factors of numbers. Okay, so the definition is when a number can be expressed, so written down, as the product of two numbers. For example, 18 can be expressed as 1 times 18. It can also be expressed as 2 times 9. It can also be expressed as 3 times 6. Okay, factors are whole numbers. Okay, factors are whole numbers. Right, very important. They're not decimals, they are not fractions. Okay, now this here, you'll see the strategy that I've went through there, right? It's self and 1. I've went to 2. It's even 2 times 9. Then I've went to 3. What's the pair with 3 that makes 18? For the product, the timesing, the multiplying, it's 6. Would 4 work? Right? Ascending, descending. What would be the next whole number? It would be 4. What would be the next whole number here? Descending would be 5. 4 times 5 is 20. We're then too far. Then we'd have to go 5 and something similar. So that's one strategy. Okay. Another strategy I would like to share with you are using these. Right? They're integer chips. So let's take an example. Let's do the factors of 8. Okay, so there's 4, 5, 6, 7 and 8. Okay, we can do anything we like with them, right? We could make some patterns with them, okay? How does that help us with this? Well, that doesn't, right? Playing about with them is very key to you getting used to using concrete resources. What you'll notice here, right, you've got two numbers which can be represented by a multiplication which represents a rectangle. Okay, so how can we make this into a rectangle? 1, 2, 3, 4, 5, 6, 7, 8. There's a rectangle. We're going to write it as length, which is along the side, times breadth. So initially, let's write that down. It's 8 times 1. Right, it's a product. 8 is a product of 8 and 1. 8 times 1. Can we make another rectangle? This is where you can play around and say, well, yes you can. We can make a rectangle which is 4 by 2. 4 by 2. Okay. And then you can start playing around and say, well, I can do this as well, which is 2 by 4. Right? Now 2 by 4, 2 times 4, are the same whole numbers as 4 times 2. Right, so we wouldn't duplicate that. So there you have it. The factors of 8 are 1, 2, 4 and 8. Okay, written in ascending order, the smallest to the largest. Let's add 1. Okay, let's do the factors of 9. Let's look at 9 then. Let's start every single time with itself and 1. 9 by 1. Can we make another rectangle? No. Oh, what's this? A square? A 3 by 3? What does that then tell us? if 9 can be represented by a square, then 9 is also a square number. So the factors of 9 are 1, 3 and 9. Okay, so again, we wouldn't duplicate the 3 there. Let's take 2 of them away. Let's do the factors of 7. Okay, so what can we do with 7? 1, 2, 3, 4, 5, 6, 7. So we've got our 7 by 1. Can we do anything else with it? Well, probably noticed that it's not even. So we can't do that array. Can we do anything else? Well, it's going to be 1 short there as well. So really, that is all we have for 7. So the factors of 7 are 1 and 7. What type of number is 7? Well, 7 has got 2 distinct factors. Therefore, it's prime. 9 can be represented by a 3 by 3 array. So then that's square. It's a square number. And 8 has got 1, 2, 3, 4 factors. 4 distinct factors. Okay? 4 factors. Square number. 1, 2, 3. There's a question for you. Do all the square numbers have 3 distinct factors? Do all the prime numbers have 2 distinct factors? Okay, there's something for you to have a think about for the next video. Okay, thanks for watching.